Imagine standing on a cliff overlooking a battlefield not of armies, but of life itself, microscopic, relentless, invisible. Space is the prize, and the combatants are ancient, primal, and tireless. Every drop of water, every sunbeam, every grain of sediment is a contested resource. Here there are no generals, no strategies drafted in halls put. A war is underway, written in cells, currents, and chemical signals. Episode 9, Battle for Space. Beneath the surface, cyanobacterial mats stretched like fortified cities, each filament a soldier holding ground. Oscillatoria rise and glide, layer upon layer, intertwining and vying for photons. Their filaments sway rhythmically in currents, creating living barricades against Formidium and Nostoc, whose own filaments push aggressively into contested corridors. These rival mats compete for the same space, the same light, the same nutrients trapped in the sediments beneath. Expansion is a constant tug-of-war, subtle yet unyielding, shaping microhabitats and forcing smaller organisms to adapt or vanish. Amoeboid predators move like shadowy assassins through the spaces between mats. Amobedium and other ancestral amoebic extend pseudopodia, testing crevices, sensing chemical trails, and striking at unsuspecting bacteria or tiny Even the slightest miscalculation can lead to starvation or death. Yet these predators refine their hunting strategies daily, tracking oxygen pulses, nutrient hotspots, and prey movements. Their presence shapes the distribution of microbial populations, driving prey into refuges where oxygen levels are lower or mat coverage is thicker. Flagellates, agile and versatile, twist through the turbulent currents above the mats. Early euglena ancestors balance phototrophy and predation, harvesting sunlight while seizing bacteria drifting in the water column. Some carry nitrogen-fixing bacteria, converting local chemical gradients into pockets of fertility. Their mobility allows them to exploit gaps in mat coverage, outmaneuver amoeboid predators, and even redirect microcurrents to flush prey into waiting mouths of other ciliates or amoebae. Every flick of a flagellum is a decision, a strategy, a calculated maneuver in this microscopic battlefield. Ciliates themselves have begun to manipulate the water. Vorticella-like ancestors anchor on sediments and mats, using cilia-generated currents to draw in bacteria while simultaneously pushing competitors away. These movements alter local chemical gradients, oxygen flows, and prey availability, effectively turning sections of the lagoon into controlled zones of influence. Some ciliates, coordinated with neighboring colonies, creating microcurrents strong enough to move detritus, redistribute nutrients, and shape the physical environment. Subtle engineering that changes survival odds for everyone nearby. Decomposers, often overlooked, play a crucial role in this battlefield. Slime mold-like amoebae, early myxomycetes, and heterotrophic bacteria digest detritus, releasing nutrients into localized zones. These nutrient hotspots attract prey species but also predators, creating micro-battlegrounds within the larger conflict. Sediments shift daily, creating temporary barriers, channels, and pockets of opportunity. Even the tiniest particle becomes strategically significant. A grain of sand can anchor a mat, block a predator's path, or shelter a prey colony. Territoriality escalates. Cyanobacterial mats dominate sunlit areas, shading competitors and enforcing their claim. Formidium invades anaerobic patches cautiously, exploiting oxygen-tolerant microzones while avoiding oxygen spikes that can decimate vulnerable species. Dinoflagellate ancestors navigate vertical gradients, twisting to reach light while avoiding predator-dense zones. Prey species like early heterotrophic flagellates and small protists respond by retreating into sediments, hiding under mats, or developing subtle chemical defenses. Life negotiates space constantly, and the boundaries are always shifting. Predator-prey interactions grow more intricate. Amoeboid predators track chemical trails left by prey for hours, even days, anticipating movements. Ciliates flush prey into traps, altering currents and oxygen levels locally. Mixotrophs shift between predation and photosynthesis, sometimes exploiting oxygen pore pockets inaccessible to other predators. These interactions drive rapid adaptation. Prey evolve faster escape responses. Predators refine hunting tactics, and mats restructure to create defensive barriers. Evolution is happening in real time, shaping physiology, behavior, and community dynamics simultaneously. Symbioses tip the balance. Amoeboid predators harbor photosynthetic endosymbionts that buffer oxygen fluctuations, allowing them to hunt more persistently. Flagellates carry nitrogen-fixing bacteria, enriching local patches of sediment and creating nutrient hubs that sustain diverse communities. Even anaerobic refuges host fragile alliances where oxygen-sensitive species coexist with tolerant partners, creating temporary cooperative networks that enhance survival in extreme conditions. Innovation accelerates under relentless pressure. Amoeboid predators' perfect timing and stealth. Ciliates coordinate fluid manipulation for prey capture. Mixotrophs optimize dual strategies to exploit both light and organic matter, and cyanobacterial mats expand or contract strategically to defend territory. Currents, sunlight, sediment, composition, and chemical cues converge to dictate every move. Life is a chessboard in motion, and the smallest microbe can influence the outcome of the entire lagoon. Oxygen itself is a silent player. Pulses favor tolerant species, force anaerobes into hidden refuges, and redefine territorial boundaries. Cyanobacterial mats expand aggressively in sunlit areas, while competitors fragment into patches, creating corridors exploited by predators and prey alike. Microhabitats fragment and merge continuously, forcing constant adaptation and shaping future ecosystem complexity. Collective behavior emerges in surprising ways. Amoeboid predators hunt in coordinated groups. Ciliates synchronize currents to manipulate prey distribution, and mats adjust density and growth patterns dynamically in response to threats. Survival now depends on both individual strategy and subtle cooperation, hinting at the first forms of complex ecological networks. Above all, life is dynamic, experimental, relentless. Every predator strike, every escape maneuver, every filament extension, every nutrient redistribution is an evolutionary experiment. Success is survival, and failure is disappearance. Each interaction echoes forward in time, preparing the foundation for multicellular life, complex ecosystems, and the terrestrial worlds that will one day arise. The lagoon trembles with invisible tension. Every filament, amoeba, ciliate, and flagellate is a participant in this unseen war. Currents shift, oxygen pulses, mats grow and retract, prey hide or flee, predators stalk, and symbionts cooperate, all shaping the battlefield in ways far larger than their microscopic scale. These are the battle for space kingdoms without rulers, armies without soldiers, conflicts without sound. Every victory secures survival, every defeat shapes evolution, and every moment drives the next step toward complexity. Life experiments relentlessly, forging the ecological and evolutionary scaffolding for the worlds to come. The lagoon is alive, vibrant, and war-torn, a microcosm where survival is the ultimate prize, and space the most precious currency. And from this relentless struggle, the stage is set for the final shaping of Arc 1, the microbial foundations that will support forests, multicellular organisms, and the rise of life as we know it. Next episode, 10 Foundations of Life. This is HistoPrimordia, where history comes alive. Thanks for watching. Subscribe now and join us for the next episode story.